So today we're looking at wind analysis. So I'm going to start up with MasterSeries 2018. Just a quick double click there. And we'll go straight in to looking at some typical files. So 2018-08 version and license to myself. And what I'm going to look at first of all is I'm just going to go in to Master Frame. And now I'm going to come into my webinars and wind analysis, and I'm going to choose just a general frame. Now what we're seeing here is a nice little complex 1, 2, 3, 4-story building with 5 stories in places with an attic in it, hipped roofs, valley beams, the whole gamut, hidden gutters. We even have on this structure a couple of canopies, an upward facing one and a downward facing one, and over on the right, over on the left here, we have a balcony and a parapet wall just to make our life more difficult. And then we have what we call continuous canopies as well, an overhang on the structure. So I'm going to go through and very quickly I'm going to apply the wind loading onto this structure as if it's never been done before, because hopefully there's no wind on the structure at this moment in time. So under loading, go to wind loading, and the first thing you want to set up is my automatic wind loading directions. And I'm going to use my wind analysis. So once I've activated, I'm going to use my wind analysis, and I'm just going to check. I'm going to work to the Euro code. So just now working to the Euro code, and we'll just go for the single set of loading cases. So now that I've got that, what I'm able to do is to set up the directions I want to consider. And here we have the default CSCD factor for our design. Now that's a very conservative factor, and if I was to go and look at the table in or the chart in the code of practice, I would see for a 20 meter height building we are somewhere in this 0.9, 0.95. So if I was to go down to 0.95, I would be well inside my limits. So just minimize that, and I'll just change these to 0.95. You have different values for each direction because it's all based on the height to breadth of the structure, so that could change. Obviously, if you have a rectangular structure, you could end up with a different ratio in each direction, so those are 0.95. So I've set those up. I'm taking 4 wind directions. I'm going to use for internal pressure and internal suction. If I had some dominant openings in a particular direction, I could then come along and increase the pressure in that direction and increase the suction when we're going at 90 degrees to that direct or 180 degrees to that direction to allow for dominant openings in the structure. And not going to do anything else down here at the moment. I'm going to leave all that as it stands, and I'm going to come back over, and now what I'm going to look at is wind load reduction on globally loaded values. Well, actually the good news is the Eurocode, we don't really have to worry about that as much, but what we can do is if we went to full frame and we then asked it to view inclined members, we could then take all these little bracing members except for the roof. So if I just click that again, it'll go away. So I can then go and say add all of these into it and just check, are these bracing members? Well, they really are. Well, they're actually canopy members, so they don't really count those little 4 ones. So I could take those out of this group, and that would allow those to come in and not be used like in the old BS with different diagonals. You only have one set of values. These are values that are relevant for the wind without the suction or pressure on it. So just going to close that, or let's take my filter and close the filter, and we're back out. In fact, probably nicer just to work with no colors and wireframe. So now, what's the next stage? Very simply, come along and say where I'm located. Okay, site data. Okay, where am I in the UK? And we will look later on about how we add in data for overseas. I know one or two of my colleagues and clients were asking about overseas, particularly one of my clients who has got the horrible job of being stuck out in the Seychelles. So I can come along and I can say, right, SP or SK, and say, yeah, I want to locate it just here, and work with that, or say, right, I'm just on the edge of whatever town. I do have towns in here, so if I went to, it's probably not Birmingham, I'm thinking I'm probably well over, not Leeds, my mathematics, Middlesbrough, no, that's too high up. But anyway, so I can choose towns and then go near them. But more accurately, is just a very simple process. Go to a quick website called Grid Reference Finder, and let's go in to, say, Liverpool onto Birkenhead, and we'll choose out here, we're going to be building a new building for the golf club. So there's my point. All I do is I click on it, and I can grab, now it's just a wee bit obscured because, there we go, and I grab the short 6 number and 2 letter version. Just jump straight back to the MasterSeries, come in here, paste that in, press enter, and there we are, right on the tip of Birkenhead, and we lock that down. So that is the first part of our job. The second part is to look at our structure and figure out how it is rotated. Now this is a logarithmic scale, so obviously our frame is just centered on it, and I'm going to say that my frame is at 12.5 degrees off the north, so the north will be up here. And all I then do is turn around and say if I want to use the standard Eurocode or the designer's methods, and if I want to do a monumental building with a higher wind load of 1 in 120 years, or if I want to do nuclear buildings with 1 in 10,000, or I can even put in my own value. The nice thing with the own value is if you're doing something in the agricultural aspects, you can actually use that to put in a 1 in, I think it is about 1 in 25 year repeat rather than 1 in 50, and that gets your wind loads down again. All year round, of course, and 23 meters above sea level. Obstructions are all derived straight from the location, and our fetches are all derived from our topography and location, and our upward and downward wind fetches, as you can see, the downwards can get quite large, and that's it. And that's all we do in here. Very simple. We come out, but we don't have any wind loading on the structure yet. So next stage, what's the next item on the list? Wind panels. Now this is where the fun and the biggest part of the intelligence is derived. What I can do is I can come along and I can say I want to add in, and I can say I want to add in wind here and here and here and here and here, and I can't get anything else other than up there because everything else isn't on that surface. So it's intelligent enough to know when it's not on the surface. So I can come in and create my own surface, give it a name, and walk along and do the same again. But I don't need to. All I need to do is to sit back and hit auto, and the program is very intelligent. It'll run along and find all the panels for you. So what's it found? It's found our little canopy. It's found our other canopy. It's found our canopies here, our overhangs, and they're considered to be different from the main roof. It's found my lovely little balcony down here, and it's found my upstand wall, my parapet. But it's not, because this is short distance, it's thinking it might connect across there. So all I want to do is to go to that surface. So in search mode, it was this one up here is fine, and this one over here had the option. So what I'm going to do is I am going to go into member mode, and in apply, take that member off, and then we should see that everything is now as we would expect it to be. So everything there is all done nice and neat on the structure. Now, this is where all the magic happens. Because we've now got all the surfaces, and I look at it in just a normal view, if I turn on wind loading, we're seeing what I saw earlier, each of the individual panels highlighted in a different color. The colors mean nothing. But I can now say, let's look at the W1 load. So now, rotating this frame around, here we go, and we've got pressure coming along onto the walls, onto the columns, and through into the structure. So this pressure, the darker it is, the higher the intensity, which gives us a green for suction, a yellow for pressure. So suction is high here, getting lesser, high, getting lesser. And we can see how that also comes in and gives us high suction in around here, and also just been trapped by the wind loading coming around and been in here. So those are our values. If we then go and ask it to give us our coefficients, we will see the 0.6s, the 1.3s, the 0.8s, the 1.3s coming through, looking at our roof, and we see the 0.56s, the 0.6s, the 0.86s all coming through onto the structure. And we can also, so those are the coefficients, and then they're all multiplied by the wind pressures in each direction. And now we begin to see a slight change in the color because of the dominance of different directions. And we can see for this the high suction because it's right on the coast. And if you think about it, that was our north over there that we moved from the Z. So we're coming in from the west. Just put that on the top. There we go. Put it into 3D. So this is north over here. This is the west. West, southwest is dominant. So we should find a very high wind when we move around to W2. And we're getting very high suctions on the leading edges of our structure. And then when we come along here, we can see these values for our little upstands or parapets. And as you walk around, you will see also, because this is a canopy, again, it is getting a far higher pressure, and is in fact, where this is getting a positive, this is actually collecting wind and giving us an uplift on the structure. So those are your principal directions. But we also want to look at the local effects on the members, not the bracing members, but the local members, the columns and beams, when we have internal suction and internal pressure. So that's when we come down and we use P1. So P1 is going to be W1, but with pressure on the inside. So that increases the load here. So we can see the pressure is reducing this down, because it's becoming pushing here and it's been pushing out from inside. And then you will see also when I go and walk through to the S1, these values here should suddenly drop down and these increase because you're getting the suction on the inside is putting this in, whereas that's been pulled out. This has been pushed in and pushed out, so they're countering each other, and you can see some of them come down to negative. So there we have all the different wind pressures on the structure. Now, one of the nice things you can also do is you can actually turn around, and this is very useful for people who are not designing the physical structure but the cladding, is you can come along and say, well, give me all the maximum pressures. So I can see what all the maximum positive pressures are. 1.2 is what we're looking at here, 1.2 on this surface, and 0.8s, 0.9s on this surface. And if we then switch to the minimums, i.e. the negatives, the suctions, you'll see we end up with 1.85s on the leading edges, 1.2. So we can see from these two diagrams for each of the surfaces what are the maximum and minimum values on the surface. Very straightforward, very easy to work with. So that was a very quick run through, and of course those are no use without actually creating loading cases. So if I go to my loading cases, I will always do these. If I just come in and delete all my cases, just hold the control key or the shift key down, get all of those and delete them, yes, and now just go to edit cases. I can very quickly take in all the standard sets of cases, and you'll see for the lie, dead plus lie plus win, we're including in overall, external and internal, and we'll just replace all those. And now we have 89 loading cases. I'm just going to take off the wind here. So we have all these loading cases with the part 610A and 610B loads, or sway stability loads, or serviceability, or W1 loads, or P1 loads, or S1 loads, and then into the W2s, the P2s, the S2s, all the way down to the 3s and the 4s, and then some of the serviceability loading cases that we need to consider for this. So that is how simple and quick we can handle the loading and wind loading on a structure. I'd like to just take a little bit of time here to think about permeability, to think about dominant openings. As you saw, we could modify our 0.2s and 0.3s in each direction to take account of a dominant opening. But if I was to look at a portal frame, if we move from the master frame into the master port is a very finite building type. So if we go into edit and look at the wind load, you will see that we have modified these and if we take off all that, we then just have to go in and put our own values in, but automatically it has calculated the values that we shall be using on the structure, and will then apply a ratio. So it's changing these values of CPI and CSI based on the height, the span, and also if we have dominant opening. So north gable up here is okay, south gable is fine, west side, which is this one, we have some dominant openings. So with a 15-meter diagonal on the opening and a ratio of 2, we can see that we've actually increased the wind loading here up to an internal pressure of 0.6, plus the CP in the opposite direction to 0.4. So you can see how we can in here automatically add in everything. Now, it automatically calculates all this internal volume larg for us just to make our life easier. So that is a little bit of an extra, and it's something we hope to start to include in the main master frame at some stage as well. But at the minute, it is only in the master port that it's done automatically. So I'm going to look at some other types of structures. We dealt with canopies and we dealt with parapets, and we're not actually doing portals anymore, Tommy. We're going to walk through and do some back in the frame. So master frame. If I look at a balcony, there's absolutely no reason why I shouldn't have this as a parapet and this as a canopy, and it will do all the calculations as it requires. If I was to open a more simplistic structure, such as an open-sided portal, this portal is a wee bit more complicated because when we look at it, we have these sides, but it already knows that it's not supported on all sides from a wind point of view. So you would have to go in and put in your internal pressure coefficient in this direction to allow for that, and also from those two directions. But from its own point of view, looking at the panels, you will see that they are just ordinary panels, whereas this is really should be told to be wind on both sides. So it's the roof members where you tell it that it's a wind on both sides. Parapets detect themselves, and that will have an effect on the structure. Very, very simply, if we go to something a bit more complicated that tells us everything we need to know, let's look at this typical open-sided structure. It's a grandstand. I think it was for a horse racing course. But we have in here surface and surface, and then we have these edges. So what we actually have is this is a canopy, or wind on both sides, and this is wind on both sides. Now, from a definition point of view, all we've had to do is come along and tell it that this has wind on both sides. We don't say anything about this. We don't say anything about the back, except possibly the red normal to member lines had to be switched to make sure it understood which was the outside. And likewise, we don't say anything about this other than, yep, that's the correct side for the wind. So they're sitting there, and that's fully open. So this is all open seating, and then underneath is not being considered at all. So if we then look at our wind pressures, and let's just take it, for example, W1 coming right down its throat, and we look at the CP values, you will notice that we're actually getting two values here, and one is for the external wind and one is for the underside wind. So it's 0.3 and 0.8 pushing up, and back here it's 0.2 but still the 0.8 pushing up. If we look at the side panels, it's 1.3 plus 0.8. So these are the boys that get really hammered due to the wind trying to rip this to the side, and it automatically does that for you. So it automatically identifies them. If we look at the pressures, then you have the combined 1.6 here. So this is where the big wind is coming onto. And then if you look at the W values, these are the values showing what zones we consider. So it's a wind and load both sides at 5 degrees, plus 5 degrees, and plus 6 degrees in this one. So that is how intelligent and smart the wind is for canopies and parapets. You don't have to define anything other than roof members that are canopies. Everything else is looked after. Moving forward, I'm going to show you something else that we can do. If we looked at this structure, in 2018 we introduced curved beams into the structure, into MasterFrame. So physically curved members that we can design. So these are in essence single members that then have some secondary beams attaching to them, and it's working out the wind. So coming from this is an A, a B and a C, and it's doing the full curved wind analysis on this structure. Naturally, when we move the wind to being on, say, a side view, it's all the same the whole way through. It's just different slopes on the structure, and it's very straightforward. It's the curved one that is worked out nice and accurately for you. So that is a run through of the different types of structures we can handle. I want to now go and look at some of the problems that you can experience. So we're moving from presentation over to demonstration and learning. So let's open up a file, one we saw before, but in fact it's got some little hidden gems that need to be sorted, and it's coming along. And if I look at this frame and I say, oh, let's go and auto do them all, and it's all done. But hold on, what's going on here? This is a common problem people have, because in your structural model you don't have a column down here, because this is just this beam running into this beam. So all you need is those are the physical members. But from a wind point of view, we need something to define the edges, and obviously the best method of fixing that, and I'll just kill all that. Best way to do that is to come along, and I can see it's running straight down here now, and to put in a dummy member. That is a member that's only used for framing up the loads, and the loads that go onto the dummy members will then transmit back to the two nodes at the ends, so the load won't be lost. So in here I can just do a right mouse click and add, and I could just add a dummy member between there and there, and then from there to there. But you can also go from the top all the way down, and actually having rotated it, if I bring it down, I can now do this straight down, and it will actually have put the dummy member at each level. So it's now used this dummy member to frame up this panel and this panel. So if I close everything off and auto design or auto generate again, you will see that it now finds this surface and brings the load onto this dummy member and up to the node points, and likewise half of the load onto this dummy and up to the node points. So the glazing manufacturer is going to have to think about that, and he will have some sort of mullion coming down here to hold his wind. Now, the other classic problem you have obviously is if I just go to, say, this panel, I can turn around, I can say whether it is two-way spanning or one-way spanning. So two-way spanning, it's not happy because this here panel is not the right shape for two-way spanning. One-way spanning horizontally, it's happy, so it just goes across. One-way spanning vertically, again, it's happy. So if we were two-way spanning in here, we would need to have some sort of trimmer out here to distribute the load, otherwise we could be in a bit of difficulty. Now, let's think for a minute, if we were to say we wanted this row of members to be, and actually probably just to make my life a wee bit easier, we'll take this column of members. So we're going to make this column here horizontally spanning. This one will be vertically spanning, and then these last two will be two-way spanning. So how do we do that? Very, very simple. Two steps. First of all, you choose your panel and you take out, I always do it from the outside in, all the bits. Sorry, you don't need. So I've seemed to have, yeah, there we go. Yeah, that's why I'd always do it in a more meticulous order so that I get them right. So that's my first panel done. I'm going to add another panel, and this will be this one, this one, this one, this one, and this one. And I said that this would be vertically spanning, and then I'm going to add a third one, and it's going to be this one, this one, and this one. Now this time I want it to be two-way spanning. You'll notice that for the two-way spanning, part of it comes down onto the base. It assumes somehow you've got a base support. And down here you'll notice again for the vertically spanning, again that's assuming it's coming down onto some sort of base support. Now, if I went ahead and decided to show all the CP values, just close this down and show all the wind, and let's look at the wind directions. You would see, in fact, what direction did I choose? I didn't put any directions on, that's why I haven't got any. So no problem. Wind directions. Doesn't really matter if it's Eurocode or BS. We'll just go to Eurocode. Yes. And we'll choose single, and did I say yes, Eurocode? Loads, wind, back into this, and we'll use wind analysis. So we're going to have our pressure, so just double click, and we can reduce those to 0.95 if we wanted. But that's not what my concern is. My concern is that when we look at these values, they're all seen as A's, and I'm thinking, what? Because each of these panels, this column, and then this one, and then this one, are all handled separately, but they are in reality one big panel. Doesn't matter about the spanning direction. So what I am going to have to do is tell it that for classification purposes, glue them back together again. So not a big problem. Let's just go to wind panels, choose that one or that one, it doesn't really matter, one of the three, and then tell it to combine it with. So in apply mode, combine it, oh, sorry, yep, got it, and got it. So it's telling it, although that is the panel we're working on, we want it to be combined with these two for classification. So if I then go to search and move to this panel, it knows it's taking those two, and this one knows it's taking those two. And those A's will all tidy up when I'm finished here. Come back out, ask my wind directions, and it should automatically for any of the directions you should now be getting your panels and your zones. So actually it's that. There you can see A, B's and B's. So whereas before we were just getting A's the whole way length, A, or A, B, A, B, A, B. Now we're getting it all correct. And in fact it is A's on that side. And we're now A's and B's, whereas you would have had A, B, A, B, A, B. So we're now doing it correctly, gluing it all together properly into one bigger surface. I just want to have a look at my little structures and see if there's anything I've forgotten to talk about. Combined panels you've done, balconies, curved roofs, freestanding structures, overseas structures. Yes, very straightforward. Most things are the same, except when you go in to define your site data, you tell it, and we're in Timbuktu, which I always thought was in Algeria, but it's actually in Malawi. And we're going to go to user defined Q values. So in fact, everything else here is irrelevant. Topography, we're just using set altitude. Unless you know your fetches, just go for site altitude only. And then just leave everything else, user defined Q, and at that stage we just come straight back out and we go to our loads, and in fact when we are defining our wind load directions, minimizing that, we will now see that we can define for different heights the wind pressure that we're going to take. So the Q in kilonewtons per meter squared, newtons per meter squared. So 1 kilonewton is 1,000, obviously. You define for the heights that you want to consider. And it just takes that in all directions. But what it does still do for you, just as simply as ever, is when you're looking at the wind loading, it's still going to work out all the coefficients. The coefficients are universal and depending on the shape of the building and the size of the building, so the 0.8s and the 0.24s. What is then taken from our overseas site is these values, so we should see we're going to be getting values. Let me just see anything else I need to cover. Yes, tall buildings. As you all know, the wind pressure is not constant as you go up vertically. However, for most of our structures, they are constant. It's only once you get above your height being greater than the frontage, the width of the structure in the wind direction, that you start to get wind increasing. So if I turn on my wind pressure, looking at this surface, you will see that the coefficients, zooming in, are all the same. 0.3, 0.83, 0.83, the whole way up, 0.83. What changes is the value of Q, the wind that's applied to that as you go up through the structure. So as I look not at the CP but at the Q values, you're starting at 0.623. Then it's starting to climb here to 69, 75, 889, 956, 956, 956. So what do you actually end up with? Well, it's very easy to show you by looking instead at a snapshot, and I think I took a snapshot. There we go. The W1 snapshot is just one row of columns, wind blowing onto the side, and you just look at the physical wind load coming onto it, and not the dead and live load, but the W1 loads. So you can now see, and I'm going to scale these up, that you have a uniform portion, a tapered portion, and a uniform. So in essence, for tall structures, whatever your frontal B width is, that's constant up to a height of B, and from the top down for a height of B. And then the middle area is tapered per floor level. Now this only works if you've applied levels to your structure, because it uses the levels to classify the wind at each height. So you do need to have specified wind levels all the way up through your structure, and one for roof, so that you actually get them used. So again, tall structures, we can do them very easily. So let's have a wee quick look at the questions. Is the angle from north essentially from the x-axis of your global axis? It's actually anti-clockwise on the z. So if I go back to the full frame, and get rid of all that and look at our frames. So that's our x. 0 north is z. So as you look in the plan, that will be our north unless we start to rotate it, and it is rotated anti-clockwise. So 15 degrees would take the north and swing it over to here. Can you get the wind panels to model without a ridge member? Yes, what you're doing is you don't need Adam to add in a physical member. You just add in a dummy member. You know, in reality, the purlins are going to do some structural good on transferring load from one end to the other and things. Putting an 88.9 tube is one way of doing it, but most certainly, if I was to go to my little portal that I'd created here, and if I was to take these members out, the structure's okay because we know we have internally purlins. If I was to go and say, right, let's delete these, and say apply, we then couldn't get these in as a surface. But what you can do is you can add in dummy members. Now, when you're in area loading, you can right mouse click to get dummy members. But in general, to create a dummy member is just a member. And you just say, it doesn't matter what this is, just say it's a dummy member. And then just go from there to there. And you will actually see that it's put 3 members in. So it's in grey because it's a non-physical member, but that is enough to define your surface. It's enough to define your surface in this roof. It was enough to define our 2 surfaces in our 2 glazed walls that didn't have a member at the intersection. It's enough in normal area loading to define members. Can we take account of funneling from nearby buildings? Absolutely. If we were to take this back wall here, and we were to turn around and say, look at the loading, there is an option to put in the funneling distance in here to allow you to overwrite the default values. So there's actually a ratio that you input of B, you know, that width as against the distance to the other side. So obviously if it's very close, it could be something, I would assume, 0.5. The code will tell you it's either going to be 5 or 0.2. I'm guessing that it might be 0.5, and that'll give you a far higher value of wind when you're blowing down through. So yeah, funneling is not a problem at all. Interestingly, When you're looking at your roof loads, you see they disappeared because I deleted those. If I now come in and add in the roof panel, now it comes in with the dummy member. You can override any panel and put in your own CPE value, your external pressure value in each direction. So you could, for example, put in a value of 0.15 for very low or 1.15 for quite high on that wind in that direction on that panel, and override the default. You also have the facility to input the dead and live values. So if you didn't want to put the dead and live in as a separate area loading, you can do that in here at the same time. Not normally done, but is possible. Can you provide a summary of the key steps to take when applying wind loads? Barbara, it's actually quite straightforward from wind analysis point of view. You walk through the 4-5 options, and perfectly honest, I would probably consider bracing members to be the first thing you do. Certainly before you define your wall panels, the bracing members should be done. But other than that, that would be a reasonably straightforward So bracing is the one thing you have to tell it. If I didn't tell it that this was a bracing member and this was a bracing member, it starts to get a wee bit funny. And it's the same in normal area loading. If I now go to loads, wind panel, walls, and you look at this. So what it's done is it spanned from here onto this member and from here onto this and this member. So the bracing has taken loading, which is not what you want, and this is why we set these members to be bracing members. So if I come along and said, actually, that's bracing and that's bracing, you don't define the edges as being bracing member because they're still needed to find the edges of the panel. And you then return to your wind panels and just delete them all and recreate them all. You'll see it's a single panel from here all the way over to here. So that allows you to get around the bracing members. Do you have to set the heights of all the time? Okay, the heights, if we're linking into frame analysis for more wind, which is hopefully what you should be doing, then it's going to grab everything out. But if I go to create and I go to create levels, it's going to automatically try and attempt to find levels at sensible positions. So let's go and look at this and put some Y values on. And it's going to say, well, there's something going on at 2 meters. I have something at 4 meters and something at 5.5. So it's created 3 levels there for you. Likewise, in the frames, it'll do the same. In big frames, it'll go and create all the levels pretty automatically for you. If I was to kill them all and then just say lightning, it's going to try and attempt them and give me those 4. So I could turn around and say, well, actually, I don't need that one. I just need a level at 4, which is the E's, and a level at 5.5. So then everything looks after itself internally. And in fact, if you have those levels and you walk into your site data, you will see somewhere along here that it will have set up the 4 and 5.5 without editing as being the 2 levels we want to get the wind information back at. So there's my 2 sets of information and there's my 2 sets of Q, since at the minute I haven't defined any directions for it. It just gives me the 2 maximum values because I didn't set up the directions as being 15-degree intervals. So, and you can go and change those at any time. There's absolutely no reason why not. Okay, Tim is asking, is wind analysis available by default as a PowerPad 100, 500 members? Okay, Paul, the wind analysis is first of all purchasable with any version of MasterFrame, Masterport, Master PowerPad. It comes as part of the building design suite. The wind analysis also will work with MasterFrame Pro added in. When we come to PowerPad, as of 2018, you get wind analysis for frames up to 100 members. So just like other limitations in PowerPad, it's up to that 100 member limit. If you have PowerPad 500, then you would need to add in the full wind analysis to get it to do it on structures above the 100 member limit. With a canopy, you wouldn't normally use CPI, but use the local combined. That's correct. I mean, the canopy is not going to take your CPIs. It's going to take your basic CPE, but it is still going to take. I'm sorry, not the load on both sides. So, if I was to go back to my favorite structure with a canopy, that grandstand. If I rotate this and I take the wind in direction 1, there we go. There is your values, your coefficients. If I take the values, 0.87, 0.88 and 0.627, when we go to P1, that increases due to the internal pressure. This doesn't change because this is a canopy. This is an internal surface with internal pressure, so it has distinguished between the two very, very simply. And again, if I go into S2 or S1, I should see this value reduce and this value not change. There you go, internal suction, so uplift and suction cancelling each other out. This hasn't changed, so it does look after itself very, very well. What info do you use for the Irish grid references? Brilliant question. So let's go and put this in Newton yards or somewhere close to that. I go to loads, I go to my wind panel site. At the minute I'm here, I'm going to change it from a GB site to an Irish site. So notice it's I and then a single letter, 3 numbers and 3 numbers. Now, back to my little grid reference finder. Well, the nice thing is that grid reference finder down here has another brother site called Irish Grid Reference Finder. Off it goes. So Newton yards is somewhere down here somewhere, or well, it's down Patrick actually, I think is where all the racing takes place. Somewhere right here I think is where it is at. So if I say yep, that's exactly where my map is, my location of my new building, you'll see it gives you a single letter, 5 and 5. So I need to copy that. Unlike the GB, it doesn't give us the reduced format. All we need to do is jump back, take this, and I just put a couple of spaces in here, paste that in, delete meters and tens of meters, delete meters and tens of meters, so we're down to 3 and 3, delete the space, press enter, and lock it down, and you should find that we're in Downpatrick. So anywhere in the north or south of Ireland is best done using the Irish version of Grid Reference Finder. And that is how simple it is. I am going to thank you all very, very kindly for coming along to this webinar.